it's recorded, but TLDR probably just shared internal. So Sam, we'll get you recording after. Cool. I'm gonna pass off to you guys whenever you want to start. I'm sure people will trickle in.
So from Reuters side, I will be presenting. I don't know if you guys can hear me.
Yep.
All right. There should be also Asim. I don't know if he's also present, but I will kick off the presentation. Let me know whenever everyone is ready, and I will start.
I think we're good. Take it away.
So okay, I will start by sharing my screen. Meanwhile, let's see if it works. Desktop 2, and let me know if you can see my screen.
Yep, we can see your slides.
All right, perfect. So tonight, can I start, right? Everyone?
Yeah, you
Okay.
should be good. It's recording. People might trickle in every now and then, but it's already in.
All right, so tonight I will be presenting a paper that came out from Writing in the Margins, Writing in the Margins, Better Inference Pattern for Long Context Retrieval. It's a paper that involves long context and how we leverage the KV cache to make long context modeling more effective. So I will do a little technical but not so technical presentation, and later we can deep dive into the details of the paper. So let me open the chat so I can see what everyone is writing. Meanwhile, while I'm talking. All right.
Yeah, I think Umar, you can just ignore the chat. People are gonna be it's
All
gonna be
right.
really buzzy. And there's gonna be a lot of people like, oh wow, that's so cool and everything. Yeah, Vibhu and I will take care of the chat for you.
Perfect.
If something super crazy pops up, we'll let you know. Otherwise, we'll take care of it.
Perfect. All right. So I will skip the part of what is a language model, but okay. The language model is a probabilistic model, and that leverages the prompt to generate what is the next token. And how we generate text with the language model, we do it iteratively, so one token at a time. Most of the language models nowadays are based on the transformer model. And in the transformer model, basically, whenever we have a prompt, the first thing that we do is we put this prompt into the memory of the language model that is known as the KV cache, which is basically the keys and values in these transformer layers. And the operation of creating this initial KV cache is known as prefilling. So the first thing that the inference engine, which could be VLLM, which could be TensorRT, or any other inference framework that you're using, the first thing that it does with your prompt is doing this prefilling. And if you're interested, actually, the prefilling is one of the most expensive part of the language of processing a prompt, because it has a quadratic cost with respect to the computations and so on with respect to the memory. So imagine that we have a prompt called Austin is a city in, a prompt that says Austin is a city in. And then the first thing that we do to generate text with this prompt is we prefill it into the language model in the KV cache. And then we leverage it to generate tokens, one token at a time. And the KV cache is this kind of memory in the language model, in any actually transformer model that is autoregressive, that if it contains some tokens, then the language model will leverage them. If it doesn't contain those tokens, then the language model cannot leverage them. So the language model only sees what is inside of the KV cache. So what happens is, to our prompt, Austin is a city in, the first thing that we do is we do this prefilling, which puts these tokens into the KV cache, which is one for each layer of the transformer. And then we generate what is the next token by asking the language model what is the next token. And suppose the next token is the word Texas. We take this token Texas, we keep it in the KV cache so that the language model can leverage to generate the next token. And then suppose the next token is a comma, etc., until we generate the entire response of the language model. Now, we have seen that in the past few years, prompts are becoming longer and longer. So we started with 2000 context window to 4000, 8000, 32, 64, 100, and now we have reached millions of tokens. This means that you can send to an entire book to the language model, and you can ask the language model questions about this book. However, with great prompts comes great responsibility. And the reason is the following. So imagine you have a very long prompt. Suppose that you have a book and you want the language model to answer questions about this book. Suppose that this book is like 1 million tokens long. If you do the prefilling of this 1 million tokens prompt in the KV cache, the language model will actually not be able to do that because, as I said before, the prefilling is one of the most expensive operations that we do when inferencing language models. Why? Because it's quadratic with respect to the sequence length in terms of memory and also in terms of compute. So language models actually cannot prefill the entire prompt in one single pass in the KV cache. So what they do is they do it by chunks. This is called chunked prefill, and it's an experimental feature that has been recently introduced in VLLM, but it's probably used in more sophisticated inference engines at major companies. So what we do with the chunked prefilling, basically we split the prompt of the user into multiple chunks and we prefill each chunk step by step. So suppose that the user sent an entire book, which is made up of 10 chapters. Now, the chunk, usually they are of a fixed size. This doesn't mean that the chunk has some contextual meaning. It may not be the first chapter of the book or the second chapter of the book. It could be just be the first 4,000 tokens of the prompt and then the next 4,000 tokens of the prompt, etc., etc. So we prefill the first chunk into the KV cache. Then we prefill the second chunk in the KV cache. So now the KV cache contains the first chunk and the second chunk, then the third chunk, etc., until all the prompt is inside of the KV cache, which can then be leveraged to generate tokens. This is intuitively very similar to how a student would read a book. For example, imagine a student is given a book to read and then to answer questions, a question about this book. What the student would do, the student would read the first chapter, and now the brain of the student contains information about only the first chapter. Then the student would read the second chapter, and now the brain of the student contains information about the first chapter and the second chapter of the book, and then etc., until the student reads the last chapter. Now the brain of the student contains information about all the chapters, and then the student will be given the question. And the question, and then the student has to leverage the information that he has read from the book to answer this question. However, the student would struggle to do it. Why? Because intuitively, when you read a book, the moment you start reading the second chapter, you can have already forgetting what is the first chapter about. So what is a better strategy that this student could do? Well, the student could read the chapters, and while reading, it could take some annotations. And this is what we do with writing in the margins. So because for very long prompts, we are already forced to split the prompt into multiple chunks to do this chunked prefill, why not leverage the partially prefilled KV cache to generate some annotations that can be then be leveraged to improve the model's capability of extracting information from this prompt. So basically, writing the margins from a technical point of view works as follows. We have this very large prompt. We split it into chunks because we are forced to split it into chunks. We cannot prefill the entire context into the KV cache. We prefill the first chunk, and then we add, after the first chunk, we add a prompt that tells the model, okay, use the text above to instruct information about the query. And the query is the question that we want to get an answer to. So now the KV cache contains the first chunk and this prompt here, and we leverage it to generate a few tokens, which is this margin annotation. And then this is another trick. You can delete stuff from the KV cache, only from the end. Why you can do that? Because a language model is an autoregressive language model, is an autoregressive model, which means that every token depends on all past tokens, which means you can delete stuff from the end and regenerate it eventually. But you cannot, of course, delete stuff from the beginning or from the middle because it would invalidate all the future tokens. But you can always remove stuff from the end. So what we do is we prefill the first part of prompt. We prefill this instructive instruction. We generate a few tokens, which is the margin annotation. Then we can delete this margin and this instruction that we have added. And then we prefill the second chunk. We then append another prompt, extractive prompt. We generate a few more tokens, which is the second margin. So the second margin will depend on the first and the second chunk. Then we delete these second margins tokens. We delete the extractive prompt, etc., until we have processed all the prompt. And this is a visualization that we have also put in the paper. So basically, imagine you are given a very large prompt. So what we do is we prefill the first part in the KV cache, and then we extract information on what is present in the KV cache, and we call it the first margin. We then also can classify these margins, and in the paper we also show that actually the computation and the prefilling of the margins, the computation of the margin and the classification of the margin can be overlapped inside of the same request in the batch, so you don't need to have another request in the batch. But this is okay, a little KV cache tricks for optimizing the inference. So what do we do with these margins? Basically, we append them at the end, before asking the question to the language model, because our goal is, okay, we have this very big context and then we have some question. So what we do, instead of just asking the question, the model may not be able to find it. So we generate these margins and then we append them right before asking the question. And then we ask the model the question. So now the model can also leverage these margins, which are present right before the question, to better answer the question. Why these margins are why this margin will be leveraged by the language model? First of all, because the instruction that we use to extract them is an extractive summary. So we ask the language model to extract information using the prefilled KV cache on knowing what is the query. So the margins are relevant to answer that particular query. Why do we add these margins at the end before asking the question? Because a few months ago, there was a paper called Lost in the Middle. Basically, it says that, and it's actually true, basically it says that with the relevant information that we are trying to extract from this prompt, which could be very large, is present either at the beginning or at the end of the prompt, then the language model will very likely be able to find it. However, if this information is present kind of in the middle, then the language model will less likely be able to find it. So that's why we add them to the end. So it improves the language model's ability to leverage this information. But does it even work? So yes, we have proof, and we show in the paper a comparison of pre-trained language models. So first of all, we are not fine-tuning any language model. We are not changing anything. This is just a different way of utilizing something that is already being done, which is the chunked prefill of the KV cache, to improve a language model's ability to leverage long context. So it can be used with any transformer model without fine-tuning, just by doing this inference differently. That is, don't just blindly prefill the KV cache, but prefill chunk by chunk because you are forced to, and then leverage it to extract these margins, and then leverage all these extracted margins at the end to...
That if I make sense, and I'm just writing code for you and building it. What you're asking me to do...
Sorry?
I think someone had mic unmuted. I just muted them.
Accidental, yeah. Go ahead.
So yeah, in the paper we have a proof that it helps the language model, pre-trained language models, without any fine-tuning, to better utilize long context. And we provide a few benchmarks. As you can see, for example, smaller models have a better more improvement. So here we have, for example, long context. So the generic pattern that we use for long context, so just the context and the question, whatever the benchmark is. Then we have reg, which means basically that we we extract, instead of giving the entire context plus the margins and then the question, we are basically extracting each of the chunks separately, asking the language model which one of them is relevant, and then only providing the relevant ones, which is what we would do in reg. And then asking the language model to leverage only the relevant ones at the end, or the writing in the margins approach, which is all the context plus the margins that were extracted during this chunk, the prefill, and then the question at the end. Now, how is this different from a prompting strategy? Because you may be thinking, okay, but we can already take a very large prompt, split it into chunks, and then use the language model to kind of summarize each of these chunks independently, and then send it to the language model again to answer the question. Well, it's a matter of cost. So let's talk about cost. Imagine that we have this very big book made up of 10 chapters, and then we have a question at the end that we want to get an answer to, which is what is the answer to life, the universe, and everything. Now, what writing in the margins would do is would prefill the, if you don't use writing in the margins, what you would do is you would feed the first chapter of the book and then extract some margin with that. Actually, let me show you this other slide. Then you would take the second chapter of the book and then extract a margin with that, then the third chapter of the book and extract a margin with that, etc., etc. Suppose that each of these chapters is 100,000 tokens. Then the cost to generate the margins, and suppose that the margins are really small, it's more or less 1 million tokens, because 100,000 tokens multiplied by 10 chapters is around 1 million tokens. But then you need to also send the entire book plus these extracted margins again to the language model to generate the answer, and it would cost you another million, because the model has to reprocess this prefilling again of 1 million tokens. So it would cost you 2 million tokens, but with writing in the margins, it would cost you, for 1 million prompt, more or less, it would cost you 1 million tokens, because you don't have to re-prefill the entire context, because you have already prefilled it. So the KV cache is growing, and you're extracting some information, and then you don't have to repopulate it, which is what you would do if you treat each chunk independently, and then do kind of like let's say the chunking that we commonly do. So what are the advantages? Well, it's compatible with any transformer model. There are other advantages that I want to show you in a video that I made. So let me show, this is on my LinkedIn post. I don't know if you can see now, again, my screen, right? It's a full...
Yeah, looks good. We see the LinkedIn video.
Perfect,
Yep.
okay. So we have a large document, suppose 1 million tokens, and then we have a question like how many employees were hired in 2006. Now, when we have a very large prompt, it must be prefilled in the KV cache by chunks, and this operation is called the chunks prefill. So what happens with chunk prefill is that you take the first chunk and you prefill it in the KV cache. Then what we do is we add to the KV cache this extractive summary prompt, which is, for example, use the text above to extract information about the following query: how many employees were hired in 2006? And then we generate tokens using whatever is inside of the KV cache, which is the first chunk plus this extractive prompt. And suppose that we generate a few tokens, which are visible now. We take these tokens, we save them, so we decode whatever is generated using the tokenizer, and we save it, and then we remove it from the KV cache. Now, if you are looking from a implementation-wise point of view, you don't actually remove from the KV cache. You just, usually the KV cache allocation is static, but even if you use VLLM, it's done using the so-called like paged attention. So you actually allocate pages of KV cache actually. Basically, it's not like you are removing stuff from the KV cache. You are just resizing the tensor, which is actually O1 operation. So it doesn't have additional cost. You just keep track of how many tokens there are. So anyway, we take this margin, we save it somewhere, and then we prefill the second chunk to the KV cache. And then we again add another extractive summary prompt. And then we leverage it to generate the second margin, which will depend on the first and the second chunk of the prompt, etc., for all the chunks. So we will have a list of margins. And then we can also classify these margins. So we can also say because some of the margins may be the model hallucinating, or the model just saying, I cannot find this information, or etc. So we can also classify them. We can either use an auxiliary classifier, or we can use the model itself to classify them. And we show in the paper that you don't have to actually create a new request to the model to classify these margins. You can actually overlap the generation of the margins with the classification of the previous margin using the same request in the batch. Does the margin pertain to all previous chunks or only the current one? All the chunks up to that margin. So the first margin, only the first chunk, the second margin, the chunk 1 and 2, the third margin, chunk 1, 2, and 3, etc. Because we want to leverage the pre-filled KV cache. Okay, so we classify these margins, and then we append them at the end. And then we append the question. And then we generate the answer, the final answer. So the advantage is that, as I said before, we exploit chunk prefill of a large prompt to generate intermediate summary. So we are exploiting something that we are already forced to do, but we are not leveraging it right now. So it's kind of comes for free, just with a minor, let's say, compute, because you have the cost of generating these margins, but you avoid the bigger cost of prefilling. So if you just use chunking techniques, like you can do with the long chain, for example, you pay twice the cost of prefilling. If you do this system, you don't pay twice the cost of prefilling, which is very expensive. And to give you an insight on how expensive is prefilling, basically, in most cases, so whenever you work with OpenAI or with Cohere or any other provider, whenever you send a request, your request is always overlapped with the token generation of other requests. So the first time your prompt comes to their server, they are overlapping the prefill of your request with the token generation of others, because the prefilling is compute bound, because it's very expensive computationally, while the token generation is memory bound. So to always utilize the GPU fully, they kind of schedule together one prefill with multiple token generations. So it's compatible with any off-the-shelf language model without any fine-tuning, and we show some benchmarks in the paper. It improves the ability of any language model to extract relevant information, so solving the lost in the middle problem. And another cool thing that you can do is basically, because now you generate these margins while prefilling the prompt, you can also feedback this margin to the user, and the user can classify them for you, like a thumbs up or thumbs down. So it adds a human in the loop. And also the user can visualize the progress of how the prefilling is going. Because when you have a very, very large prompt, I believe that because the cost of prefilling is quadratic, it will become really expensive to prefill it, and the user may have to wait many seconds. So you can actually give a feedback to the user of how much context has been processed, and you can actually leverage the waiting time of the user to give you thumbs up or thumbs down on these margins, which can actually improve the ability of the language model to use them. And the user can also early exit. So the user found the relevant information in one of these margins. The user can say, okay, stop inference. And the user would not have to pay for, all the context being processed. And we also provide an implementation. So if you go to this URL, so github.com/writer/writing in the margins, you can find our implementation on how we actually do this stuff with the KV cache. I don't know how to delete this line. It's so annoying. Let me check. I believe it's annotate and then delete, clear all drawings. Okay. So if you go here, you can see what we do. Basically, It's a simple it works with any language model. Here we provide a demo with the Llama, Phi, and Quen. Here we show, for example, this code that is present here in the GitHub repository matches exactly the code that we present in the paper, which is the pseudo code that you can see here. So how we split into segments and how we prefill into the KV cache and how we delete stuff from the KV cache. So it's present here. So here you have a very simple, like we also show the state of the KV cache at each line of code so that the user can understand what is happening here. And this is the code for the method that we use to delete stuff from the KV cache. All right, let me see if there is something that is missing here. Yeah, here we provide the comparison of how it differs from reg and how it differs from just long context processing. Questions? All right, let me check.
You in the chat, but Eugene is like crushing it, answering the questions in the chat. Thanks, Eugene.
My pleasure. Thank you for taking the time to share with us about the paper and even preparing slides.
Yeah, this okay. The slides were from another talk I gave in the company, so it's reusing stuff. But yeah, thank you everyone. So let me go through the question if there is something in the chat that I can answer. Yes, this is not we are not doing any change to the model architecture, so you don't have to fine tune anything. You don't have to change anything. Like can you use this stuff with like a lang chain? No, because it requires a modification on how the inference engine is using the model. So it because when you work at the KV cache level, you cannot just work with the APIs and tell them to remove stuff from the KV cache or overlap stuff in the KV cache. But it doesn't require changes to the model, to the weights of the model. That's why we talk about no fine-tuning here. Is the extractive summary prompt just the instruction to produce the margin? Yes. So the instructive summary prompt is basically a prompt that we add after each chunk to extract relevant information about that query. So it's not just to find the relevant information, but about the specific query, because this inference pattern that we introduced is specific for those prompts that are composed of a context plus an instruction. So we always know what is the instruction. That's why this is, I mean, the best use of this inference pattern. Now in the paper we also show how chunked prefill works at the KV cache level. So if you are familiar with how the KV cache, with the query, the keys, etc. But we also show how to overlap the computation of the margin with the classification of a margin. And this is exactly actually the representation of the KV cache during the prefilling of one chunk and how it can be overlapped with the classification using the same language model and the same request in the same language model.
Sorry, could you go deeper into overlap? I don't know where like overlap happens. Is it between the different chunks, or you're overlapping the different chunks with the margin?
Let's talk about overlap. So I am talking about, let's say, first visualize it. Let's say here, we do have a nice representation of that. So it is here. So you extract a margin and you need to find a way to classify it. You can either use an auxiliary classifier, so you use another model to classify it as relevant or irrelevant, or you use the same language model to classify. But if you want to use the same language model to classify, you would need to create another request in the batch, because you don't want the classification request to visualize anything in the KV cache. You just want to ask the language model, okay, I ask a language model to extract information about this query here. So is Ethan Washington in a marble floored room? And the language model extracted this stuff here. Is it relevant to the query or not? If you want to do it, you would need to create another request in the batch. But we show here that you can actually, in the chunked prefilling, so let's go here, chunked prefilling. In the same request in the batch, so when you do chunked prefilling, basically what you are doing is you are adding the first chunk to the KV cache. So the keys and the queries are the first chunk. So this is C1 that you see here. And then what do we do is we actually add after this, we also want to add an extractive summary prompt, right? And then we use this one to generate tokens. So now the token generation has how to say, this is the part of the prefilling of the first chunk. So the first chunk plus the extractive summary, and then we use it to generate tokens. So this is the first margin token generated. Usually we pre-allocate the KV cache. So the KV cache is not like growing tensor. We pre-allocate it with a fixed number of, let's say, padding tokens, but they are not really padding tokens. They are just unused spaces in the KV cache. And then we replace them with the tokens that are actually generated from the language model. So suppose that you have these unused tokens, which I call padding here. Basically, what do we do? After we have generated the first margin, we delete this margin, right? And also the instructive token. So what we are actually doing is we don't delete anything. We just change the pointer position of the KV cache on how many tokens are used. So now the pointer, suppose it's pointing here. Then we can prefill the second chunk. So the second chunk needs to attend to all its tokens in a causal way. So each token in the second chunk needs to attend to only itself and all the previous tokens in the same chunk, but also needs to attend to all the past tokens of the first chunk that was already prefilled. And we also need to prefill the instructive summary prompt, which can visualize all the past tokens that it has seen. But while we can also skipping some tokens that we reserve for the generation of the margin, we can also prefill the classification of the classification instruction for the first margin, which was generated before in the previous step. And then during the token generation step, so this is the prefilling along with the instructives, the prefilling of the second segment. After we have prefilled the second segment along with the first generated margin, we can generate the tokens of the second margin, but classify the first one, which we already obtained in the step before. So we are generating two token sets here and the token generation step in the same request now. One using only the part relevant to the first chunk, the second chunk, and the extractive summary of after the second chunk, and one using only, as you can see, this is the attention mask, right? And one is only using the part that is relevant to the classifying the first margin that was extracted in the previous step. So you can do it also like this.
Thank you, Uma.
Yeah.
Oh, sorry, there's a question in the chat. And I think from your explanation, I think the answer is clear. So when you are creating the margin for the second chunk, you're actually paying attention to the first and second.
Yeah. Okay, so you can change the attention mask to only look at the latest chunk. However,
yep, that's exactly the question. Yeah.
Yes, but it's not possible actually. I mean, let me clarify why it's not possible, because the KV cache is made up of contextualized tokens. Is actually these tokens are not single, they are contextualized. So the token number 1 in the KV cache is a contextualized version of the token number 0 and 1. The token number 2 in the KV cache is a contextualized version of the token 0, 1, and 2. So if you tell the model to only look at the last tokens, you are creating an autoregressive model that is generating the logits of P of, let's say, x10, but only looking at P of x9, x8, which are contextualized tokens that contain information about 7, 6, 5, but you are not using them. So you are actually going out of distribution. So this is why you can. Yeah.
Thank you.
How much of the KV cache do you prefill with a chunk versus leave it? You can actually if you use, for example, VLLM, they use this thing called the paged attention. So actually they prefill, they allocate one entire page, which is actually a lot of tokens. So it's like another chunk, which is more than enough to generate the margin. So what are the next steps for this? Well, the next step is for sure we are sending it to conferences. Get it published and presenting it around. But we are recently focused on long context modeling, and actually we are looking at how long context modeling, long context can be better leveraged. So we will be working in this field. Actually, we will be how to say, we'll be researching a lot in this field.
I think there's a question from Ahmad. How are the queries chosen for the query-based summarization? I think
No,
it's a classification, right?
yes, okay. So the queries, basically, we work with a prompt that is made up of context plus query. So we always know what is the query. That's the structure of the prompt that we work with. What's the use case at Writer that led you to this research? Well, I am personally very interested in long context modeling, and I am given the freedom to research what I like. And Writer is also interested in long context modeling, so things intersect, and here we are. And then, we have many smart people working together. We did a few brainstorming, and yeah. What's the latency you see for typical request? Well, there is no kind of latency increase because of this. You are just paying more price to generate more tokens in intermediate cases. Of course, what would happen is that you have before, for example, you need to process the entire prompt at once. So chunk prefilling, chunk prefilling, chunk prefilling. Now you have chunk prefilling with some token generation, which will slow down the entire request, but you are actually getting something back, which is feedback, and you are getting the possibility to see what the model is actually seeing at each step. So you get human in the loop. So the human is waiting, but is waiting, let's say, with some feedback, which is nice to have progress bars, right?
And maybe this is sensitive, do you happen to have a demo of showing how this actually looks like in the user interface? Or is it something that we have to sign up to Writer to actually see?
We don't have that, but we are working on demos. Yeah. Here we have, we have a concept on how it would look like. Yeah.
Thank you.
So, okay, in some cases, the writing margin does not work well as other methods. There are two factors. First of all, because each margin is kind of a summarization of what is present in the context, it depends highly on how good that model is at summarizing. So the better the margin, the better the information it will extract, and the better it can be leveraged. So if you think about the student, if your note-taking skills are not so good, then probably your notes will not be useful. The second thing is actually the comparison here that you see with reg. This reg, actually, we put ourselves in the worst condition possible, which is let's help reg beat us, but then actually reg doesn't beat us. How? Usually in reg, what you do is you have these chunks and you extract some vectors of these chunks, and then you match them with dot product or whatever with the query. What we did with reg actually is we asked the language model to see if the reg, yes, it was charitable, because we asked the language model actually to see if that particular chunk is relevant. So actually, you have a 70 billion model telling you if that chunk is relevant compared to extract some vector and map it with dot product. I mean, we helped reg a lot. So actually, if we did actually a reg approach, like a naive reg approach, we would do much better.
Thanks, Umar.
Do we have anyone else have questions or want to come on screen to just ask Uma and Sam more questions?
If there's nobody else that is interested, I actually am having a little bit of trouble wrapping my mind around why chunk prefilling is so much more efficient. I looked at the sort of the reference, and I kind of get the idea, but maybe you can help me understand the intuition.
Okay, it is not, first of all, chunk prefill doesn't exist because it's more efficient. It's because we need it. We must do
Okay.
it. So when you prefill a chunk into the language model, let me show you actually. Here we have the KV cache representation, right? So when you prefill a chunk in the language model, let's say this one, chunk number 1, C1, you are generating a quadratic matrix, as you can see. If you have 4 tokens, you are generating a 4x4 matrix, which is prohibitive to generate for very long prompts. Like you imagine you have 1 million tokens, that's 1 million by 1 million matrix, where each of these values is actually a dot product of a vector. And then the computation cost of that also, it would really be very slow. And the GPUs are really good at parallelizing. In this case, when you have a lot of operations, they will actually be serializing this operation. But anyway, the problem actually is the memories of this prefilling, because when you generate this matrix, it's really huge and it doesn't fit.
Yeah.
So we are forced to do this chunks prefilling. And then we are doing, okay, we do this chunk prefilling, so chunk 1, chunk 2, chunk 3, chunk 2, but we are not leveraging these chunks that we are, because we are forced to do it, right? So it's slower than just doing it in one pass. But since we are already forced to do it, why not use them?
Yeah, no, I definitely, I think I got most of the paper, just the chunk prefilling part, the background,
But if
I
you
don't
want
quite understand.
more information on chunk prefilling, I can give you some references. One is the VLLM page. They are actually in the VLLM now. They are it's an experimental implementation. There was a NVIDIA explanation on chunk prefilling, so I will send a link later. NVIDIA published recently an article about chunk prefilling, but basically, prefilling is the most expensive part of working with long prompts for language models. That's why, yeah, they need to.
So, but why, I guess I was having trouble understanding why that is. Is it just because it's quadratic? And so you have to break it up into chunks? Is that
Maybe I can take a stab at it. So you
Sure.
can imagine.
So
Go ahead.
let's look at attention mask here. Here I'm generating the first margin. How
Yeah.
many dot products am I doing here? I am doing, I have already 7 tokens in the KV cache, and I am generating the 8th token. So I am doing 7 dot products. So token generation, which means generating 1 token using whatever is in the KV cache, is linear with respect to whatever is inside of the KV cache. Prefilling the KV cache is quadratic, and mostly because it's quadratic, it's very expensive. So we are talking about something that is linear with quadratic. So, and if you consider about prompts, long context, if you are working with a 2 million context window, 1,999,000 will be prompt. Nobody will ever generate more than, let's say, 5,000 tokens. So the biggest part, the most expensive is actually prefilling.
So just to get an intuition here, the other extreme is that your chunk size is 1 token, right? So what's the trade-off?
So what they do is basically they try to put as big as possible until it fits in the GPU. So they usually suppose I think good numbers are like 4,000 tokens or 8,000 tokens or something in this range. And as I said before, usually the token generation is memory bound, means that the limitation is only given by how much your KV cache can hold, so the memory can hold in terms of KV cache, while prefilling is compute bound, so to maximize the GPU utilization whenever you work with OpenAI or Cohere or what, they just overlap your new request with other people's old requests. So while they are generating tokens, they are also prefilled, so the GPU is utilized 100%.
Okay, yeah, no, that's helpful. And if you do send those links, I'll definitely read them. Thank you.
Is there a break-even point where at like a certain context length, it becomes more valuable to do writing with margins than just using the LLM by itself? Like where the compute equals out, or is it altogether margins is better?
I believe, okay, writing in the margins, it's like you read a book and you have margins versus reading the book. I think it's always convenient to read the book with the margins because you are actually paying the price for that, right? It's not something that comes for free. You are actually paying the cost of generating this margin. So you're actually putting there some effort, and then you leverage it. Then what we could do is, okay, does it always help? So far, yes. So it's not like something that you get for free, right? So you pay, and is it worth it? So far, yes. And if it's always worth it, so far from our data, it's always worth it. Like it
Really,
doesn't
like
depend on,
even if
maybe
you're
for
literally just
small
talking about a
prompt,
chunk, if you have
sorry,
like a sentence
yeah,
instead of a book. Oh, really? That's
then it's
crazy.
not, yeah, then it's not convenient, because in that case you are not even doing chunk prefilling, right? Because if you have only small context, then they just prefill it at once. But when you have
Okay,
long,
yeah,
yeah,
makes sense. Once
But
you start growing chunks.
I think the topic still stands, right? Like, let's say you've got a paragraph and your chunks are sentences, or you've got a page, right? So you've got 1,000 tokens and your chunks per se is every sentence relevant. So some form of highlighting is, you have a one page, but every sentence you highlight was relevant or not. At that level, it's kind of negligible to throw the whole thing in a prompt versus, do I want to highlight 7 of the 40 sentences and do this approach? I think that's the other non-extreme, right?
yeah. So basically, whenever the context can just be prefilled in the KV cache without any chunked prefilling, I believe it's not worth it to use it. But if it's long, then it helps. And it helps much more than chunking separately like we do with the APIs, right? With the long chain, because you are paying twice the cost of prefilling. In this case, we are only paying once the, and we also prove in the ablation studies that actually it's always convenient to send the context plus the margins, never just the margins. So you can see here this ablation context compression. So if you only send the margins or only the context, is always worse than providing them both.
Context being the whole, right?
Yeah, the entire book.
And so building off that ablation, let's say you've got a model that doesn't have the context, and you have to do some sort of chunking splitting. Let's say you have a total context of 8,000 tokens, and you have a 1,000,000 token document. There's approaches of how you can process chunk by chunk and then combine. So with the what you would expect is you could, for each chunk, do this writing with margins approach at every level, and then scale that down with how many ever steps you need. Is that intuition still pretty accurate?
I believe with 8,000 how to say context window, I believe that the latency would be higher, right? Because you at each step you are adding more. Yes, at that kind of latency, it's even more convenient to just do independent chunking and generate in that kind of lane, because if you can always split the context into chunks, and then you just send multiple requests, and you can pay the price of prefilling in that kind of range. But when you are talking about 64,000 tokens, that start making more sense to use this approach. So for that level, I think it's all the traditional approaches, they work fine.
Any other questions?
I think another question that came out was why now? Why, right? I mean, why nobody thought about this before? Because actually, we didn't have very long context models before, and we were not forced to even do chunked prefilling. So as you can see from VLLM, they have this feature is an experimental feature right now in VLLM. So it's because right now we need this chunked prefilling and everyone is doing it. So that's why we have this. So it's always, innovation is always starts from some problem that you face and some need that you have. So right now we have this need and we have the capability. So that's how we came up with this.
Awesome. We have a few more minutes. If anyone else has last minute questions, please feel free to ask. And big shout out, thanks to the writer team for presenting.
Thank you guys for listening. You are welcome to send us your questions. We have a GitHub repository. I suggest watching the code. It's really very commented, and it follows the same kind of pattern that we shared in the paper, so it's easily understandable for everyone. And we did a lot of nice tricks. Like one of the tricks is like you can always delete stuff from the end of the KV cache, and you also know why now.
It's an interesting project if anyone's interested. On Fridays, we have a similar AI in action section where we try to take practical outside of paper. There's the code up, there's the paper up. If anyone wants to run it and present it, share their learnings, it'll be a really good learning exercise. But that's always there. I guess we got a question from Jimmy. Any future work in this direction?
Any future work in this direction? Well, for sure, we will keep working on long context and how we can better leverage long context. So there is another kind of problem with the long context, which is how language models use long context actually depends highly on this attention mechanism and how the softmax works. So we have seen with the paper called sync attentions that actually the language model allocates a lot of because when you do the attention mechanism, you are doing a weighted sum over the tokens, and each token is given a weight, and we see that most of the weight is given to the first few tokens. So there is a lot of research in this area. Recently, I saw a few days ago another paper came out called the sigmoid attention, which is also studying the distribution of these logits in the talk. So I think the attention mechanism will play a big part in how we can extend the long context. So if we can also fix this part here. So I am very interested, in the KV cache and optimizing long context modeling. So we are working in this direction because it's needed by the market, and also I like it, and I think it's cool to be able to analyze an entire book or an entire code base instead of hoping that the RAG finds the right one.
Awesome. Well, big shout out to Writer team. Always great to have you guys present. Sam is in Discord as well. I'm sure he'll relay questions and stuff. We've got the recording. We'll share it with your team. I don't know what you choose to do with it, but next week we've got Swix. He'll be presenting some of the Strawberry, Q-Star, Quiet Star, all those papers. So he'll be doing that next week. And then the following week, if anyone's interested in anything, volunteers are always open. I posted a few papers in Paper Club. I think there's also the Mistral stuff. So if anyone wants to lead, pop in there. Otherwise, next week, Swix is doing Strawberry and Star stuff. So that's on the agenda. Cool. Thank you, guys. Thanks, everyone.
Okay, everyone.
Take care.
Thank you.
Vibu.
Yes, I was just about to end the meeting. Yes.
Vibu, question. Is there any way you can copy over the comments? I'm trying to do it, but it seems to like lazy load. Like as you scroll up and down, it's really painful.
Let me see if I can extract these comments. Do you know if they normally get saved as a Zoom recording?
I'm using.
You can click Save Chat. Where is Save Chat? Anyone want to help me out? Chat. There's
I was able to copy the comments without any problem.
The file is usually saved on the host computer in a folder like Documents, Zoom, Meeting Date and Time. If you're on Windows, see, there's a chat log file that, as long as it was recorded.
I got it. I just saved the chat. I'll throw it in Discord. I have a text file of it.
Yeah, cool. Slides would be great too if we can grab them. Get it all.
I'll ping them. I'll ping them right now.
Perfect.
Thanks, guys.
Sweet.
All right, GG.
All right, thanks. Bye.
See ya.